Hey everyone, we're looking at a continuation of notes 1.2 where we'll be finding sums of polynomials. So the first thing that we're going to want to do is underline each like term in a different way. So if you take a look right here, we've got 3x squared is like 4x squared. So I'm going to underline these together with the same color, okay? And every time you have a new like term or a new set of like terms, you're going to combine them or collect them together. So, for example, right here, 3x squared and 4x squared would give us 7x squared. Remember, we just add the 3 and the 4 and the x squared stays the same. Why are these like terms? Because they have the same variable and the same exponent. Then we've got negative 2x, and negative 2x is like positive 8x because they both have x's on them. So if team negative 1, 2 points, and team positive 1, 8 points, that means team positive 1 by 6 points. So this is plus 6x. And then lastly, our last set of terms that we have here is positive 5 and negative 6. And positive 5 and negative 6, when I put them together, team negative wins by 1 point. So I get minus 1. And then the last thing you need to make sure you do is make sure your answer is written in descending order or in standard form. And just a reminder, that means you're going to go from the highest exponent to the lowest exponent, which our answer already is written in descending order. So this is my simplified answer. And now Mr. Steele is going to teach you some of these next examples.
So looking at our examples here, when I'm adding polynomials, exact same thing. I'm looking to see which terms are like, and I'm just going to add together those like terms. So I have descending order. I'm going to do my y to the power of 2's first. I have 8 of them, and then I'm adding 3 more. So that gives us 11 y squared. I then have positive 2y plus 7 more y, so that gives us 9y. Those two terms that we have remaining are unlike terms because we have a different number of y's being multiplied in each one. Next example, same thing. I have my 3, or x cubes, or x to the power 3. I got my x to the power 2's, x's, and my constants. So right now, we see that they're both written in descending order. This is what would help us out. I'm not trying to figure out, what the new order is going to be, trying to determine what the highest degree term is going to be. They're written in that order so that I can easily work from there. So I have 3x to the power 3 plus 7x to the power 3, so that gives us 10 x's to the power 3. I have minus 4x to the power 2 plus a negative 9x to the power 2. So those are both, I'm adding two negatives. So that gives me negative 13x squared. I have a positive 4x plus a positive 2x. So that gives me a positive 6x. And then I have a negative 2 plus a positive 4, which gives us positive 2. Okay. For this one that we have for question 3, it starts to stump us a little bit. We can see that I have r to the power 4. I don't have any more of them. I have an r to the power 3 here. I have an r to the power 2 there. I have an r to the power of 1. And then I have 2 constant terms. So until I get to those constant terms, I have unlike terms in this entire polynomial addition. Well, that just means I have nothing to add to the terms that I already have. So I would just rewrite the ones that don't have any like terms. And I'm going to do so in that descending order. So all of these terms so far have no like terms to combine with until I get to that positive 3 plus 7, and we're left with 10. So if I have no like terms to put together, the term that I have just stays how it is. Last one, we have a whole bunch of stuff going on. So just take your time, try to pick out the largest degree term. I hope they're written in order. That usually helps out. So I see I have a y to the power of 3. I have 2y squareds over here, or y to the power 2. I have a negative 9y, a plus 8y, and a minus 3y. And then I have a positive 2 and a minus 12. So once again, write them in descending order. So I have 12y to the power 3. My y squareds, I have 6y squareds plus 2 more, so that's 8y squared. So even though that's within the same polynomial, I'm just collecting those like terms. I have negative 9y plus 8y, so that brings me up to a negative 1y just in that first polynomial. And then I'm adding a negative 3y, so that's going to give me a negative 4y total. And then I have my constants, which are the positive 2 minus 12, which is negative 10. Okay. So that's how we add together our polynomials. You can see that I'm using highlighters to help me out. I would recommend something like that. Or if you're underlining, if I didn't have highlighters, then I would use something like, if I didn't have highlighters, I might quickly number like terms like that so I know which ones go together. Okay. The ones down here, very similar. You're going to add up, but we're applying it to perimeter. I can try doing these real quick. So I have the perimeter of a square, which is 4 times that side length, which in this case is 4 times 5x. And if I have 4 5x's, then that's 20 x's total for our perimeter. For this, it looks like a trapezoid's perimeter. I'm going to assume that the top and bottom are parallel. Our perimeter is once again just adding around the outside. Anytime I'm subbing in, always sub in with brackets. I'm just going right around the outside, adding together each of the sides. So we'll underline our largest degree term first. Looks like those are the c squareds, or c to the power 2. I then have my c terms, and then I have my constant terms. Constant terms. So putting together my leading term first, I have 9c to the power 2 plus 8c to the power 2, so that gives us 17c to the power 2. I have minus 3c plus 17c plus 2c, so that gives us 16c. And then I have a minus 4 plus 3, so that gives us a negative 1. So our perimeter expression for the trapezoid is 17c to the power 2 plus 16c minus 1. I have no clue what the actual perimeter is until I know what the value of c is. That is how we add polynomials and collect like terms. If you guys have any questions, please feel free to bring them to class.